Back to the next session of videos on stoichiometry 3.1 formulae, learning outcome part 4, part 2. This is the core, construct word equations, simple equations to show how reactants form products including state symbols. I'm going to go into more detail now. Hopefully we'll get a better idea of what's going on. Here are a few examples of word equations and their corresponding simple equations that show how reactants form products. Is a formation of water. You can see here. You can see hydrogen, 2 molecules there of hydrogen. So you've got 1 molecule here. There's 1 molecule there. There's a second one. And then you've got 1 molecule of oxygen. We get 1 molecule of water and a second molecule of water here. Here's what it looks like. It's a word equation. We've got hydrogen here with oxygen to form water. And the symbol equation shows us a lot more detail in terms of how many molecules of hydrogen together. You need 2 molecules of hydrogen with 1 of oxygen. You want to put that in, and you get 2 lots of water. 1, 2, and we get the appropriate state symbols: gas, gas, liquid, or gas, gas, gas. Here's the formation of water with explanation, a bit more detail for you. Read through that at your own leisure. Remember, it's balanced off here. You've got 1, 2, 3, 4 hydrogens, and you've got 1, 2, 3, 4 hydrogens, and then we've got 1, 2 oxygens, 1, 2 oxygen. So you can see that obeys the conservation of mass theory, where the total number of atoms on both sides of the reactants and product side are equal. Here's the combustion of methane. Here it is in a diagram model here. Here it is, the chemical formula. And there it is as a word. We've got 2 lots of oxygen here, 1 carbon, and 2 lots of water. Here it is the word equation, methane plus oxygen. Remember those on your left-hand side are called reactants. And then you've got 2 products here, P for products. Here it is as a balanced chemical symbol equation. Notice they're showing the coefficients. 2 waters, you can see 1 water here, second water there. You've got 1 lot of carbon dioxide. And notice this 2 represents 1 oxygen, 2 oxygens. And then we've got 1 of these. You don't have to put it in, but I'm just doing it. It doesn't make a difference here. You can put 1 there if you like also. Here's the explanation behind it. Combustion of methane. So in this reaction, methane reacts with oxygen, 2 lots of them, to produce 1 lot of carbon dioxide and 2 lots of water. Remember, G in the reactions represent the gases. Remember, the conservation law of mass is obeyed here. We went through it again. You can see there's 4 oxygens here, and you've got 1, 2, 3, 4 oxygens there. You've got 1 carbon here, 1 carbon here, and you can see 1, 2, 3, 4 oxygens here, and you've got 1, 2, 3, 4 oxygens. So you can see that all the atoms on both sides of the equation, reactants and products, are equal, hence obeying the conservation law of mass. Here's another example. Formation of sodium chloride. So you can see here in sort of the modeling here, we've got 1 lot of sodium, second lot, and then we've got chlorine gas, diatomic molecule, bond together, and then we've got these structures representing, not correctly, but individually what sodium chloride looks like in more simple form as an ionic compound. Here it is as a word equation. Sodium plus chlorine gives sodium chloride. Here it is as a balanced chemical equation. You notice there's 2 sodiums because that's 1 sodium chlorides. There's 2, the coefficient here. We've only got 1 of these, so that's why there's only 1 of those. And we've got 1, 2 of these, coefficient, 2 lots of sodium. We've got state symbols, what they are. As a reactant, sodium is a solid metal reacting with chlorine gas to give you the ionic solid sodium chloride, 2 of them. Here's an explanation, a bit more detail. So you can see here that in this reaction, 2 lots of sodium react with 1 lot of molecular chlorine gas to give you 2 lots of sodium chloride compound. S is the state symbol that represents solids. G is gas, obeying the conservation law of mass. And the final one we'll have a look at that you'll come across, neutralization reactions, when you get the topics acids and alkalis. But here's a classic example. You can see sodium hydroxide in its diagrammatic form or model form, hydrochloric acid, to form 1 lot of water molecule and 1 lot of sodium chloride compound. Here's what it looks like as a word equation, a bit more detail, a bit more complex. There's hydrochloric acid, that's that one there, HCl. Then we've got sodium hydroxide, which is this one here. So the beast looks like sodium chloride, and we've got water, the tick or the dumbbell. There it is as a chemical symbol equation. We are giving a bit more detail, explanation here. So you can see that 1 molecule of sodium hydroxide reacts with 1 molecule of hydrochloric acid to form 1 molecule of water and then 1 molecular ionic compound of sodium chloride. This obeys the conservation law of mass, just going through it. There's 1 oxygen there represented here and here, so that's balanced. There's 1 chlorine there and there, that's balanced. We've got 2 hydrogens here, bounce off 2 hydrogens here, and then we've got 1 sodium here, balanced off 1 sodium here. So it obeys the conservation law of mass with the number of type of atoms on the reactant side balanced with the number of type of atoms on the product side. Read the bottom bit there, it illustrates the conservation law of mass. Here's some quick 3. Here's some general word equations you come across again, and simple equations given. So you've got propane plus oxygen, that's what it usually gives, carbon dioxide and water. We have excess oxygen. You've got another reactants, metal and a gas. A metal and a gas together, in this case, the gas is oxygen, you get a metal oxide, denoted by MO, Mo, and a metal plus an acid, you get 2 products, salt plus hydrogen gas. You'll become more familiar with that when we go through it in the different topics, acids and alkalis, and so forth. Okay, using this information, we're going to answer some questions. So have a look at that, have a read, absorb it like a sponge. Here we go with the first question. Remember to pause these questions, don't go straight to the answers, have a go at them. You learn by doing. Well done. Here we go. Number 1. What are the products formed when propane reacts with oxygen? Number 2. Write a full word equation when sodium reacts with oxygen gas. And number 3. What are the products formed when a metal reacts with an acid? Second part to the question 3. Name the salt form when given the metal magnesium reacts with hydrochloric acid. If you can't remember the reactions, just stop and go back through the video before you answer those questions. So if you've answered those questions now, we're going to go on to the answers. The answers are, for the first one, what are the products formed when propane reacts with oxygen? The products formed in terms of words, carbon dioxide and water, or you might have written CO2 and H2O, it doesn't matter. Write a full word equation when sodium reacts with oxygen. This has to be in words. So sodium plus oxygen gives sodium oxide as a product, ionic compound. And the third question, what are the products formed when metal reacts with an acid? A bit more complex, but using the previous information you can work it out and name the salt formed. So here's the products formed are a salt and hydrogen gas, and the name of that salt is called magnesium chloride. More to come on the lessons looking at acids and alkalis, and we'll get to know how we work out naming our salt in acid and alkali reactions. I hope you enjoyed watching this video. Remember to subscribe and like. Remember, you can truly achieve your potential with Rob Macbeth.